Lesson 2.1 is all about simplifying algebraic expressions. So we are going to go over some vocabulary. Hopefully most of this is review. Okay, if it's not, it's okay. We will figure it out. But just know most of this should sound semi-familiar. Okay, so first we're going to talk about some vocab. So we're going to start with terms. Terms could be constants. They could be variables. They could be, or both, like a constant and a variable together. Now remember, a constant is just a number. So they could be numbers, they could be letters, they could be a number and a letter together. But what's important about terms is that they are separated by addition or subtraction. Separated by addition or subtraction. So an example would be like 3x plus 5 minus 2x squared. With that, we have 1, 2, 3 terms because we have 2 operation signs. So we have the 3x, and then it's split up with the plus sign. We have the 5, and it's split up with the minus sign, and then we have the 2x squared. So we have 3 terms there. The first term is a combination of constants and variables. The second term is just a constant because it's just the number 5. And the third term is a combination of constants and variables, okay? So the terms, I think of the terms as the pieces. They're the little pieces that are separated by addition and subtraction, okay? The coefficient, I think I actually just talked about. The coefficient is the constant. Oh, no, I was talking about a constant. The coefficient is the constant in front of the variable. So 3 from the 3x, that's a coefficient. 2 from the 2x squared, that's a coefficient. So the number in front of the variable is the coefficient. The variable is the letter that represents a number. So it could be X, Y, Z, W, P, L, M, N. We try to stay away from like O and I because they look like numbers. I don't like to use Z a lot either, but you'll notice if I do a Z, I draw like the little dash through it. Have y'all seen a Z like that before? That's what I do so that it doesn't look like a 2. But we try to pick numbers or letters that don't look like numbers. L is another one I don't like to use a lot. Stuff like that. Okay, so we talked about terms, coefficients, variables. Now we'll talk about like terms. Like terms have the same variables with the same exponents. Same variables with the same exponents. So that could be 2x and 3x. Those are like terms. That little sign there, that's an and sign. It's not a plus sign. It could be 5x squared and 7x squared. They just have to have the same variable and the same exponent with them. So I couldn't do an x and an x squared or a y and a y squared. Next one is distributive property. Last one, yay. Last one's distributive property, which is multiplying an entire expression multiplying an entire expression by a constant. Okay. Have y'all heard of distributive property before? Yes, yeah. Okay. So, like I said, some of this will be review, some of it will not, but most of it should be. So our example here would be like 3 parentheses 2x plus 4. And so our distributive property is that 3 is the constant, and we're going to multiply by that 3 by everything inside the parentheses. So we're going to multiply it by the 2x to get 6x, and then we're going to multiply it to the plus 4 to get plus 12. Next, we're going to simplify by combining like terms. So this should be, once again, old news for you. You should feel comfortable with this. Now, some of the numbers might not be the best, but we should be able to match up like terms with like terms and non-like terms with non-like terms. You can just look at it and do it. If you want, sometimes I will like highlight or circle in different colors my like terms. So I just circled my X terms in orange and my constants in pink, so that I can say, okay, the orange terms are coming together. So 2x plus 3x is 5x. And then 5 plus 2 is 7. 6, 7, 5, 7. So we're combining like terms there. So for letter B, what 2 terms could I combine together?
Negative 5a plus a.
Right. And what is in front of that a?
1.
A 1. So what's negative 5 plus 1?
Negative 4.
Good. Negative 4a. And then what else can I combine?
Negative 3 plus 2.
And that would give me negative 1. So negative 4a minus 1. We can have decimals or fractions, so that's what C and D are going to show us. For letter C, I've got an x squared and an x squared. I've got a 5. And then I've also got a 3x. Will the 5 and the 3x be able to be combined with anything?
No.
No, because there's nothing else like it. But I can combine the 2 x squareds. So I have 2.3 and 1.7. I'm going to add those together real quick. Oh my gosh, no. My thing is freaking out. So I have 7 plus 3 is 10. That gives me a 3. No, that's lies. That's a 4. So I have 4x squared. Now, I'm going to go ahead and reorder this because when we're writing things in math, we like to write them from the greatest exponent to the least exponent. So you see how that 3x is at the very end, but the 5 is before it? We like to have the constants at the end, okay? It's not something that I would take off points for, but is a good practice to get into if you plan to continue to be in honors classes. So we're going to write the 4x squared first because that has the biggest exponent. Then we're going to go ahead and write the 3x because that has the second biggest exponent. And then we're going to write the 5 last because it doesn't have a variable with it. It's a constant. And then lastly, with letter D, I have negative 1/2 b plus 1b. So when we're combining, we have negative 1/2 plus 1, which it would be like 1 over 1, right? So when I'm adding, do I need common denominators? Yes, I do. So what would my common denominator be here? 2. So I need these both to be over 2. So 1 over 1 is the same as what over 2? 2 over 2. Good. Okay, now that I have common denominators, I can add. Do I add the numerators and the denominators? No, just the numerators. The denominator stays 2. So what's negative 1 plus 2? 1. Good. It's 1. So my answer is going to be 1/2 b. So for distributive property, we're taking the constant that's in front of the parentheses and we are distributing it by multiplying it to everything inside the parentheses. So for A, I'm going to multiply this 3 to the 2x, but I'm also going to multiply this 3 to the y. The biggest thing I notice with distributive property is especially when there's something with 3 terms, I see people leaving off the last term. I literally draw those little loops or curves or whatever when I, like on my keys, like that's my genuine math work. Like I actually do that so that I make sure I don't forget one. So we have 3 times 2x, which is 6x. And then we have 3 times y, which is 3y. And we're going to do the same thing for the next 3. I want you guys to take a few minutes. For the fraction ones, actually, no, just take 60 seconds, do letter B. So with C and D, there are fractions in front of our expression. Now, being said math teacher, I can see by looking at these problems that these fractions aren't going to be an issue, okay? When I have something that's 1 over a number, like 1 over 2, 1 over 3, 1 over 5, 1 over 7, it's the same thing as just dividing by that number that's on the bottom. So if I have 1 over 2, I can also just divide by 2. If I have 1 over 3, I can just divide by 3. And you might notice that at least with most of the numbers, they divide evenly with 2 and with 3, okay? So for letter C, when I distribute this 1/2 to the 6a, it's really like doing 6 divided by 2, which would be what? 3. So it's 3a. And then 1/2 times negative 2b. It's the same as doing negative 2 divided by 2, which would be negative 1b. And then 1/2 times negative 20 is the same as doing 20 divided by 2, which is negative 10. Now you can only use that trick when there's a 1 on the top, okay? If there's any other number, then we have to actually multiply the fractions, but when it's a 1, we can actually just divide by the number. We can do the same thing with letter D. So if I distribute with the 1/3, I have 1/3 times 6a, which is the same as 6 divided by 3, which is what? 2a. And then I have 1/3 times 12b. So that's going to be negative 4b. Now this last one, is 20 divisible by 3? No. So off to the side, let's do 1/3 times negative 20 over 1. Because I can't use my trick there because it's not divisible. Can I cross simplify the 20 and the 3? No, I can't do that either. So I literally just have negative 20 over 3, and that's what I leave it as, negative 20 over 3. If you wanted to turn it into a mixed number or anything like that, more than welcome to. But you don't have to. You can just leave it like that. So with this extra practice on the next page, I want you guys, you've got about 10 minutes until lunch. I want y'all to get started on it. You probably won't finish it, but I want y'all to get started on it, okay? I will periodically put the answers up, but you can work in your groups. And then we will go to lunch in about 10 minutes.